Good afternoon. I'm Yandu. I'm with Shopify. I'm a director on the data platform engineering team. And earlier this year, we started migrating our data center from on-prem in Chicago up to Google Cloud. Shopify is the leading cloud-based commerce platform. We started in 2012. We have about 600,000 users, active merchants, spread around 175 countries. And together, they've sold $63 billion worth of merchandise. So that's really Shopify by the numbers. But what Shopify tries to do is also make a place where an individual brand can, an individual merchant can build its brand and build their brand and really find out the voice that their unique voice and be able to bring that to market. And we try to support them through our customer support, our ecosystem of apps and developers, and really just try to make sure that they've got every advantage that they can. So this is why we're here. My senior VP of data in the fall of 2016 said all data processing needs to be in the cloud by Q4. Fortunately, he didn't say what year, but it still kind of had us thinking and worrying. And so that's what he said. Implicitly, he also said, we can't have any SLO violations. Our customers still need to be able to get their data insights. And the business, Shopify, needs to be able to answer the questions it has, and also no data disruptions. So we couldn't lose data, we couldn't corrupt it during this migration. So we managed to do it, and I'm really excited to tell you about it. But first, I want to talk a little bit about the data platform as it was in the DC and sort of how it grew up. So this is going to be a really brief introduction to our infrastructure. So this is how it started. These servers arrived the same week I did, and my bootstrapping onboarding task was to bootstrap these nodes. It took me 2 days to realize that our HDFS nodes didn't have any hard drives in them. Once we figured out why we couldn't install an OS, everything kind of went smoothly. So from there, once we had the machines up and running, we installed HDFS as our data lake for file storage, Yarn for our compute, and running all of our jobs. The jobs primarily are Spark, and that's where all of our ETL happens, modeling the data. And then finally, about 2 years ago, we introduced Presto as our query engine so that we could make all of HDFS data available and queryable via SQL to our analysts and the rest of Shopify. So final state, we had 11 petabytes of storage. By the time we migrated, we were using about 9.5 of it. Between Presto and Yarn, we had around 250 compute nodes. We added 80 terabytes of data per day. This is net new. The amount that we actually produced was a lot higher, around 250 terabytes, but that was, with our lifecycle management, really net new was just 80 terabytes. And then finally, we run 25,000 ETL jobs per day on that 9 petabytes of data. So from pretty humble beginnings, we grew to a pretty big size, and we were starting to feel the strain of managing this infrastructure with a small team. We went from buying servers to buying racks to building out data cages. So what does it do? Basically this, just lots and lots of ETL. This is where people do their exploration, their modeling, where we build data insights both for our internal customers but also for merchants. So it breaks down sort of the way we think of it logically into data acquisition, which is how the data comes in. This is data pulled in from our MySQL shards and also our Kafka message bus, plus third-party services like GitHub or ZenHub. And then once the data lands, data processing takes over. This is the majority of the Spark jobs that then take this data, model it, and build out sort of the data artifacts and data assets that we use to power our business but also help our merchants. And then finally, we've got data discovery and access. And this is really how the data assets make it back to our customers. And it's mainly through Tableau or Mode for exploration and reporting. And then we've got Redshift as an analytic database, and then also Presto for querying and exploration. So that was the start of, that's where we were, January 2018. And then we found out our data center and contracts were up in July, so we had 6 months. So we had roughly 5 infrastructure engineers, 15 to 20 data engineers, and 6 months. So for us, we really had to focus on time to cloud. And we sort of made a bunch of decisions around that to make sure that we could get out of the data center as quickly as possible. So we were optimizing for speed and trying to also not impact our customers, like the data scientists, and really try to replace what we had and make sure that it's as much of an implementation detail as possible. So to do that, what we did was we really just wanted to lift and shift our infrastructure. We understood HDFS, Yarn, and Spark, and this is also what all of our customers were familiar with. We didn't want to burden them with having to port all of their models and all of their jobs over if we could just move it up to GCP without them seeing or having to worry about it. But as much as we didn't want to use new services, we also wanted to be pragmatic and use services where it made sense. So for us, there was an operational burden running things like HDFS. So if we could shift that operational burden over to Google, we did it. And then we also knew that we needed to get out of the DC quickly and into GCP. And we knew it wasn't going to be perfect, but we just needed to do the job and be able to get all of our data assets rolling again. So we knew that there was lots of optimizations we could do once we had the flexibility of being in Google Cloud. So we wanted to, but none of those optimizations would actually help us get out of the DC faster. So things we could do with compute, preemptible VMs, running clusters that are specific to the workload. Those sorts of things are great, but again, they wouldn't help us move out of the DC faster. So the first piece to move was data discovery. This is kind of like starting with dessert first, but there's a reason we did this. So just as a reminder, data discovery, this is really the portal into the data warehouse that we gave all of our customers within Shopify. So this is Presto for querying and also Tableau and Mode for reporting. So these are the reasons why we chose to do the data discovery first. One of the big ones is that there was no data set dependencies. Really, all the consumers wanted was the latest data. We didn't have to worry about operational interdependencies to actually generate this data. Also, we knew we were going to have to move that sort of 3.5 petabytes of data up to GCP, so we were going to have to get good at moving data anyways, so we might as well do it with a slightly lower load. And then it was also the one feeling the most pain. Presto usage took off like wildfire. We started with 4 nodes and had to scale out to 60 within a year, and it runs 25,000 queries per day across the 3.5 petabytes of data that we have. So when Presto really is our query engine and SQL engine to all of the data in HDFS. And when we look at our data lake, we think of it in 2 ways. We've got the raw data, which is what data acquisition brings in. This is really just operationalized data that we bring in, consolidate, and have a historical record of. And then there's the model data assets, which are cleaned and built by our ETL framework. So this is what it looked like in the data center. Basically, we had HDFS and Presto. Redshift was our first analytic database, and it only contained front room data. So once front room data was built via the ETL, We'd package it up, we'd ship it up to S3, load it into Redshift, and then people could start reporting off of it. Presto had access to all of the data in HDFS, and that's where it queried from. So all it needed to do was really a metadata. We just sort of say, this is the latest data, you can start querying that. This is the pipeline that we had to build for the migration. So the good news is that we already knew how to move quite a bit of data, because we already moved the data from HDFS to S3 for front room data. And then we added this new pipeline to move the front room data from HDFS up to Presto. The one part that we didn't quite have yet was for the raw data. And this is where the majority of that 250 terabytes that we build every day goes. So we had to work with our network team to make sure that we didn't DDoS ourselves, going with all this data out the front door. So our network team looked at the amount of data we wanted to move and also the latency. And this was sort of an important piece too, was that we had to go and understand what our customers wanted in terms of latency. For them, new data is generated around every 4 to 8 hours. So an extra 15 to 20 minutes of needing to wait for the freshest data was okay. No relevancy would be lost by this lower latency. So after discussing, understanding that the latency concerns that we had, how much data we wanted to move, and also wanting a little bit of headroom for growth, we decided we got 40 gigabit direct connects with Google and made sure that all data coming from our data warehouse was segregated and ran specifically over those links so that we wouldn't impact anything else in the data center. And moving this data, we'd already gotten good at sort of being, as part of our workload, uploading the front room assets, and now we also needed to upload the back room assets and register them. But this was just another step in the workflow that we already understood and knew well. So for part of our migration, we Dockerized Presto. One of the reasons we did this was in the DC, we maintained everything with Chef, our configuration management. But that wasn't going to be maintained once, Chef itself wasn't going to actually be supported once we left the DC. So we needed to move away from it. And we also wanted to have immutable infrastructure. So this is the format that we came up with. We have Presto Dockerized. It's pretty simple and easy one to Dockerize. And then we also Dockerized all of our monitoring and logging tooling. All of these run as systemd unit services. And we ran on container optimized OS. We chose that because we wanted, it's optimized for Docker, and we also didn't have to worry about somebody going onto an Ubuntu image or something and running scripts and installing stuff, and slowly the clusters started to drift. We already had a very good pipeline for version control and building out Docker containers, so we just kind of jumped on that. So once we had the nodes, we started using Google Deployment Manager to actually be able to deploy the clusters. And this gave us the ability to quickly iterate, because we didn't have to slowly stand everything up and make sure the config files were there. We could just lean on Google Deployment Manager for that. Also, Presto it's pretty simple. There's a coordinator and workers to do the work. And this gave us an easy way to start understanding how Deployment Manager works and how to actually build out more complicated clusters. And we used instance groups so that we could scale out the workers on demand. So once we had the cluster and everything up and we were moving the data, we started to run in parallel with the DC. We made sure that we could stage the data, that it was consolidated and it was reconciled to make sure that the data we thought was there is actually the data that was there. Then we opened it up for beta to some data scientists who were super eager to go and start using it because they could get away from the current cluster, which was overloaded with too much work. So after we reconciled, made sure the data was there and were comfortable with how we were deploying it and felt it was ready for production, we flipped the switch. So until now, the DC Presto was still running, and it was the single source of truth. When we were ready, we switched it over so that we made we switched all the reporting to start going against GCP. This was in late Q1 that we switched over. So once we had the Presto up and running, we also wanted to think about security a bit more. So in the DC, we secured it with VPN at the edge. But what we lost there was some auditability, because without a plugin, Presto just allows anybody to put whatever username that they want into the user field. So we knew the people that were using it, so it was okay, and there was trust within the data org. But we wanted to open it up to more than that. And so what we did was we created an OAuth proxy, which is similar to the identity-aware proxy. And basically what happens is a user will log in via this proxy in their web browser, follow the OAuth flow that they're used to. We get back a signed token from Google. Then the user can connect to the client and their proxy, and that client will proxy their request along with the token up to the server. Once it's on the server, we now have the signed JWT token that we know exactly who it is, and then we can set the username before it goes into Presto. So this gave us end-to-end auditability on all of our queries. So that was moving Presto. Now, so we kind of started with the end of the meal, and now we're going to actually sort of, I guess, set the table. So again, this is how all of the data enters our data warehouse. We pull it in from MySQL shards, from Kafka, and from third-party sources like GitHub. It's really the only place where we've got operational snapshots of the data, and this is the base of all of our ETLs. So Speedboat is the tool that we built to run our data acquisition. It's written up in this sort of unholy pairing of JRuby and Scala. It's a basic change data capture, and it produces, again, full snapshots of the operational models. And the way Shopify core is running in our DC is we're sharded, so that means we've scaled all the shops horizontally. And the data warehouse is really the only place you can get a consolidated view across all of Shopify. So Speedboat has two main phases. One is the extract phase. This is where we actually pull in the new data, and this is basically like a select star where updated at is greater than whatever. So we get back all the data that's changed since the last time we did this, and then we fold that into an existing snapshot to produce the new operational table at that time. So for moving to the cloud, we had to move to, we started leveraging some managed services. And this part was really good because it allowed another team, not just the infrastructure team, to actually be able to own their infrastructure. They decided to use Google Kubernetes engine as the extractor, and co-located that with Shopify core to be able to access all the databases. They also used Dataproc to be able to build these snapshots. This was all built on top of Spark and Scala. And then we used Google Cloud Storage for our storage engine, our storage layer. So this is how it looked. And basically, Speedboat would run its extracts from all the different shards. It would land those extracts onto GCS, and then Dataproc would pick it up, fold the new changes into the existing snapshot, and put it back down on GCS. And that's how we got the root for all of our modeling. So this is the piece that took the longest. And this is the big hairy beast that nobody really wanted to tackle. This is the heart of our data warehouse. And this is where all of the raw data gets refined and where we build out the data assets. It's insanely complex. So this is about a third of our dependency graph. That's 3,500 individual jobs, which run 25,000 times a day. So in the DC, I've mentioned this before, we have a Yarn cluster running on top of HDFS as our data lake, and PySpark is the main driver for all of our data and ETLing. So at Shopify, we started using Spark and PySpark specifically around the latter part of 2013 and into early 2014. And so we've got like a lot of legacy baggage that came along with that. One of them was that we had to be able to distribute our work across the cluster. We couldn't just run it on a single node. And this was before Yarn cluster mode was fully available. So what we had to do was Dockerize our driver, make sure that everything was there, all the native libraries, and then we could actually run that Docker driver anywhere in the cluster to spin up a new Yarn job, and we weren't confined to a single box. And again, because of PySpark, there were a lot of native libraries that we had to deal with. So NumPy, SumPy, SciPy, these were all native libraries that we had to compile and run. And it took about 40 minutes to bootstrap a new node with these dependencies. All right, so how did we migrate this to the cloud? So we, again, looking at time to cloud, we had to make a couple choices up front. And one of the major architectural changes we'd made was going from from HDFS to GCS. And this was, again, trying to deal with context-free versus context-full. So something where we didn't have any competitive advantage running HDFS ourselves. And also it's cost prohibitive in GCS or in GCP to run HDFS. So we decided to move to Google Cloud Storage. There was also the added benefit that Google Cloud Storage's API is compatible with HDFS's file system API. So it was kind of a drop-in replacement. But GCS isn't a file system, and this caused us a lot of grief. It's sort of similar if you're driving a car with an automatic transmission and then you swap out and put it in, give it a manual transmission. You're still going to be able to drive, but now there's a lot more things that you have to worry about. And for us, there were a lot of built-in assumptions with the way that our framework, for ETLs, did its job. Mainly about atomic directory moves. That doesn't happen anymore. So what we had to do was add Sentinel files to ensure that we weren't picking up partially processed data. So again, we took the same approach. We had Chef running in GCP, in our DC. And it had grown organically. The configuration management for this, for Hadoop, had grown organically. I tried for 2 months to refactor it, but then rage quit. So we didn't want to bring this ball of yarn and this mess up with us to GCP. So again, we looked at Dockerizing everything. This was a more complicated deployment than Presto, but we'd already sort of understood some of the best practices from going through the Presto migration. So we again used GDM for deploying and managing our deployments. And then we decided to use standard Google Compute Engine VMs to deploy onto. So we desperately wanted to use Dataproc, but we couldn't ever get the boot up time for a Dataproc cluster to be under 30 minutes. And that's because of all these native libraries that we had to compile and build up. So there was no way of actually amortizing the cost. We wanted to pay that cost of building once and then be able to deploy quickly. So what we did was we leaned on the fact that we had already Dockerized and paid the cost for the drivers for all of our ETL jobs. And then all we needed to do was really overlay the node manager and resource manager libraries over top. And so now we could go down from 40 minutes to spin up a new node down to 2 to 3. So this is what we ended up with. Again, it's very similar to the Presto nodes. We have the node manager running all the jobs, all of our Logging and monitoring are also Docker containers built up on container optimized OS. The one thing that we had to change, though, was the way that we launch ETL jobs because of the Docker container. We had to actually mount the Docker socket into the node manager, so when it spun it up, it would use the VM's Docker daemon to actually spawn these jobs. We had some issues too, where now all of a sudden if a node manager failed because they weren't managed by the systemd service, they would keep running headless and potentially cause some data corruption. So we had to add in some hooks into the systemd unit file to make sure that if the node manager ever shut down, we'd go and reap all of the Docker containers. So as our deployments became more complex and we deployed to more projects, and we also had more services coming online, we invested in building something we call Data Deployment Manager, which is really just a wraparound GDM to sort of enforce our best practices around how we want to package and deploy. It versions our deployments, and it also makes other teams more autonomous, because now instead of having to make sure that they configure the GDM deploy exactly the way we want to, we can automate this process, make sure that they're running the latest version, and also have the latest version of the configs. So how we manage our configs, this is something that we built in addition to the Data Deployment Manager, and this is Configurator. It's a system to manage and deploy application across our clusters. It works by keeping versioned configuration files and source control and having a sidecar container run on each of the VMs. At startup, the config, the sidecar is the first one to start up. It will pull down all the different config files and runtime information that we can get from the metadata API. And using a templating library, we can stitch these all together and put them into a mounted Docker volume, which then all the other services on that node can pull off of. So they don't actually need to know what the latest config versions are or how to stitch them together. They just need to know which ones they want, pull them down, and put them in the right place before they start up. So this allowed us to also separate concerns of building the Docker containers and deploying the configurations. And the nice thing too here is that we can now roll out config changes without having to bounce the entire cluster. The configurator will pull it down and build out the latest version of the configs, and then make sure that the services pick them up. So this is how we built out the node, and we built out the deployment and made sure that we could do the configuration properly. So once we were ready for our migration plan, once we had that, it was really just get the infrastructure ready. So the end piece that you see here with Configurator and our Data Deployment Manager, that was something that evolved over the entire migration and is still evolving. What we did and what we wanted to make sure of is, because of the tight time deadlines, that we weren't bottlenecking anybody above us from running tests or anything like that. So basically, we lied, cheated, and stole to get our first cluster up to make sure that people could start running some smoke tests. And then as we saw where the bottlenecks were and issues were, we kind of refined our process and made sure that it was repeatable faster and faster. Once we had some infrastructure ready, what we wanted to do was fire some tracer bullets to make sure that the end-to-end workflow worked as expected, that there weren't any huge performance issues or networking issues or security issues that we just hadn't thought of. We did this before we had to worry about that huge dependency graph I showed before, and it was really just a one end-to-end workflow with no dependencies. So once we were comfortable that we understood how we could run one job from end to end, we needed to look at how to stage the data and move all of the data from the DC up to GCP. And this was so that we could start running essentially a full production workload once we were confident that at least all the tooling was there to be able to run it. So once we had staged the data and started to spin up our production workload, we ran in parallel with the DC again. And this was to make sure that we could reconcile the data. And this is also a place where we made some decisions. So before the data acquisition layer, I was talking about how there's an extract phase. And that is actually, depending on when you do the extract, you might get different data. And so this is something where we now have the potential to add a little bit of wobble into the root of our tree, which just kind of gets echoed throughout the entire process. So we wouldn't have had any hope of properly reconciling the data if we introduced noise at the root. So what we did was we actually left the extracts running in the DC, even when we were running in parallel. And then we'd push up those extracts to GCP and then run the snapshot. So this way we ensured that at the root of all of our ETLs, the data matched exactly. So we ran in parallel in the DC, made sure that we could reconcile all of the data. Nothing changed. Again, we didn't violate SLOs or SLAs. And then finally, we flipped the switch again. So until this point, Presto and Redshift and all of our data that was consumed by our customers was running from data that came from our DC. So we always wanted to maintain and make sure that we had a single source of truth. We didn't want to have some data in DC and some data in the GCP and then have to synchronize. So basically, at one point, we just started to flip. We flipped the switch and started doing reporting we started loading data from GCP instead of the DC and slowly moved all of our data to have the single source of truth in GCP before we shut down the DC. All right, so that was the bulk of our migration. Again, these are the logical pieces that we moved. There was dozens of services involved in them. And so here's a brief timeline. So in Q4 2016, David gave the mandate that by Q4, all data processing needed to be in GCP. Then 2017 was pretty much all entirely eaten up by contract negotiations and working with Google. And this is a piece that I hadn't factored into my estimates when I was building out capacity and budgeting for our data center needs for the data warehouse. I kind of assumed that we'd have the contract signed and we'd be able to get going and we wouldn't need to scale as much. So it was a bit of a scramble, and it was this game of not wanting to invest in hardware that we knew we were only going to use for a handful of months versus actually making sure that we didn't violate SLOs. So it got a little tight near the end. So we managed, by April 26th, we managed to run all production out of GCP without any SLO violations or data disruptions. And as of July 1st, we shut down the data center. So one of the things that you need to think about is really, what are you optimizing for? Is it cost or is it time to migration? For us, it was time to migration. We knew that we were going to potentially be inefficient with cost. Our executives knew that, and they were okay, because maintaining two operational systems and also having to renegotiate DC contracts if we slipped was going to be much more expensive and harder to do for any longer than we absolutely needed to. The other part is really using the right tools. So for us, lean on managed services as much as possible. If you can shift operational burden away from your team and onto Google, that's a win. But you also need to understand the trade-offs. For us, we wanted to shift the operational burden of running our Yarn cluster to Google, but we couldn't because of these boot up times. And we knew that Dataproc was working on this, but at the point when we needed to make the decision, it wasn't ready yet, and we weren't ready to bet all of our ETLs on a product that wasn't in alpha yet, or a feature, sorry, that wasn't in alpha yet. So this is picking the appropriate path forward. You really have to just, even if you know it's suboptimal and it might raise the operational burden, you pick the path forward that you need to make sure that you can optimize towards what you're looking for. And then for the migration plan, really for us it was trying to iterate as quickly as possible. So we wanted to make sure that we were never a bottleneck for upstream consumers, and that we could fire these tracer bullets as quickly as possible and correct any issues that we saw. So we really wanted to make sure that we were fast, and that if something broke, we could mitigate it quickly, and then try and push the system and figure out any edge cases as fast as possible. And then for us too, it was identifying the logical pieces that we wanted to move. For us, and that dependency graph, it didn't make sense to try to move the entire, or move one piece at a time. The interdependencies were too complicated and would have slowed us down. And so what we ended up doing was, again, slicing everything vertically and managing to just move it in bulk over, and being able to isolate it to a single team that would work on moving their piece once the infrastructure was in place. So that's it. Thank you.